All right, there we go. All right, thanks for everybody for joining the meeting today. Let's go ahead and go through with the last status update meeting for February. It's today's last day of February. All right, so agenda, we got basically just the status updates for today. Haven't gotten any requests from anybody else for a separate presentation, so I'm just going to be talking at you guys for a couple of minutes here. All right, so unfortunately, not a whole lot has changed since the last meeting, so I'll go through basically the same points pretty quickly and just highlight, what has actually changed. So the documentation, I've been working on that. It's looking pretty good. A couple little kinks to get squared away here and there, but it's looking pretty good at this point. There's a couple of kind of high-level introductory overview type things I need to finish putting together, and then I'll hopefully be able to get that into the repository within the next week or two. So that's looking pretty good. Variable length descriptor support. I'm planning on getting cracking on that pretty soon, as I get the transceiver low-level stuff squared away. RxQ selection logic, I've been kind of bouncing around between a couple of possibilities here. My original thought is to just go ahead and implement the more advanced RSS logic, and then I'll get everything all wired up properly. But it's looking like that's going to be a little bit non-trivial to do. I'm not sure of the several possible ways of implementing it. I haven't really decided which is the best one. So I'm going to put that on hold for now, and I'm going to work on taking the current logic that I have and making a few updates to it so that it's a little bit easier to use architecturally, and we have a nice way to integrate this Q selection logic, which combines effectively the RSS hash that's computed by the RSS hash module and the tdest field that's provided by the application block. So combining those two to select the queue means that you can add customized queue selection logic inside of the application. Now, more comprehensive flow steering is something that I would like to implement at some point, but haven't had a sufficiently pressing need for that on my end to to spare the cycles. All right, so the next thing is the management software. And my kind of original plan for this was to make it kind of a board level core that sits at the that wouldn't really sit inside of the the standard NIC logic, but you'd have to pull in a separate module at the board level and connect it up. But after some thinking about that, I'm thinking it may make sense actually to go ahead and pull that module into the core logic and then have a parameter that you can use to turn it on or turn it off. And this will just make sure that all of the interconnection and all the integration stuff is already taken care of. You can just turn it on, and then you'll have basically another register block interface port that you can hang register blocks off of that will be only visible to the software. So as of right now, if you want to add various IO related stuff at the board, you can just hang it off of the register block that we have. Of the register block interface that we have that goes to just the standard NIC control register space. So the idea is to add a second one that goes to the management core, and anything you hang off of there will be visible to the management core. It won't be visible to software running on the host unless you talk to the soft core. So the other thing I got to figure out with the soft core as well is how exactly how the driver is going to interface with the software. It's gonna have to be some sort of memory based interface, some sort of a mailbox type protocol. I've been doing some poking around. I'm thinking I'm just going to base it off of kind of how the Xilinx board management controller stuff works. So I'll have to take a closer look at the documentation. If anybody has any ideas with regards to that, that would be great. So yeah, and hopefully I'm going to be able to get this operational within the next couple of weeks. So I want to hammer on this so I can get this and all of the transceiver stuff squared away, so we can start building on that and we can get this running on all the boards. All right, and then we have the Dty Pll Vrp interfaces, and this one I have the DRP bridge logic working at this point. So this has a bunch of synchronizers for clock domain crossing from the control register interface, which is going to be running in the PCIe clock domain, or the management controller clock domain, which might also be the PCIe clock domain, and the DRP clock domain for the transceivers, which right now I think I'm just sourcing that at 125 megahertz from whatever clock sources are available. But that one has to be a free running clock, so I don't want to source that from PCIe, so the transceivers work correctly. So yeah, not a whole lot to this. There's kind of two main components to the bridge. One of them is the actual kind of DRP side of things, which connects the DRP port on the transceiver components, so the PLLs and the transceiver channels, up to a centralized DRP port that that this bridge connects to. Well, okay, so there's two components of the bridge. One of them is the register interface block that is accessible either from user space or from the soft core, and then the other component is the transceiver wrapper logic. So the bridge is basically, the bridge itself is basically done. I've already gone ahead and committed that. The transceiver wrapper is what I'm working on now, and the transceiver wrapper, it has a bunch of multiplexing logic effectively, so that you can connect multiple channels and one PLL to the same DRP interface, and not consume too many wires going across clock domains and whatnot. But then it also has a bunch of internal registers that are connected to a bunch of signals going into the transceivers, because some of the parameters that you need to adjust are accessible over the DRP interface on the actual channels. Some of them are not. So you need to, for various operations, you have to poke various reset lines and things like that. And those all need to be exposed somehow. So that's the main thing I'm working on now, is getting all the details on that hammered out. But I did get an initial version of it running, and as a result of that, I was able to take an Iscan measurement on the Fpga. So, I showed an Iscan measurement, maybe not the previous meeting, but recently, and what I was able to do is take another one, but this one was taken with, through Corundum itself. So with the user space tool, talking to the transceivers through the driver, and we can collect all of this. We can measure the link state pretty easily. And this one is taken with Ethernet traffic running with a ConnectX-5 at the other end of the link. So that's pretty nice. Versus the previous one, I was running just PRBS data. So what I didn't try doing is, actually sending packets over the link to make sure it wasn't being disrupted, because you do have to reset the transceiver a couple of times for things to lock correctly. But this looks pretty good. And this was taken at 10G, so it goes off the top and bottom of the slide a little bit, because I didn't adjust the vertical scale. This is the highest gain setting, basically. But it does show that things are in fact working, because this is a sensible result. So what I'm working on now is the transceiver wrapper components, trying to get all the reset components and whatnot inside of that all squared away, such that we're going to be in a position that can be integrated into all the designs. All right, and then going hand in hand with this is the 10G and 25G switching, along with a few other settings on the transceivers. And the status on this is that Adam John has been working on it separately, and he has it working on a different Fpga board without using Corundum. This is basically just directly using the transceivers, and that's great. We know kind of what the process is for getting everything set up, what registers need to be updated, things like that, what signals we need access to for this to work. But I need to finish basically bringing out all of the knobs that we need to adjust inside of the transceiver wrapper. The other thing that complicates things is that when you instantiate the transceivers with the GT wizard, it generates some reset handling logic and a few other things as part of the transceiver wrapper code. And that code, it doesn't quite work when you're trying to change clock sources and things like that. Basically, if you configure channels, you use QPLL0, and then you want to switch to QPLL1, it's still looking at the the PLL locked output from QPLL0, and there's no way to change that. So what I have to do is effectively re-implement that reset logic inside of the wrapper so that the transceiver channels will actually get reset correctly. So that's what I'm working on right now, is getting that finalized and getting a couple of kinks worked out such that we can actually reset these things appropriately. But making progress on there. It's looking pretty good at this point. I'm hoping to be able to effectively replicate what Adam John has done, but using this wrapper and then a user space application to poke at all the registers necessary to change the line rate. And then once I get that working, then once I have the management core operational, then we can push this switching functionality into the firmware running on that core. All right, and that brings me to the last slide that I have here, the to-do list for the stable release. I think I may bend a couple of these a little bit, but I was hoping to get the variable length scripter support operational and the soft core implemented at least before we start cutting releases. But since things are versioned, it might be possible to do this a little bit sooner, at least cutting versioned releases. So anyway, at this point, if anybody has any questions or status updates that they want to present, I'll open it up to anybody else. I don't know if the folks from MLE have anything that they want to ask or anything they want to present about either Zinc device support or DPDK or what have you.
I guess no prepared slides or something.
No, that's fine.
But some updates, and there will be a pull request following soon with respect to the Intel RAM inference. I guess
right,
last time,
okay, for the Intel device support.
Right, because last time we discussed that until you go ahead and modify the data path units that are now outstanding to implement variable length descriptor support, for example. We want to first discuss this and see that we put this in place and we don't have to refix those also until right after you wrote them originally. So I guess that's that's a little bit inefficient. So we're just preparing this. This will patch against, I guess, three main modules, I guess. Okay. And at least one set of patches needs to be revisited later because it introduces additional failing timing paths, but fix in RAM inference. So one thing fixed, another thing introduced. But
that happens occasionally.
Right. And there is like still say two issues open that we follow up on with Intel. But yeah, we will mention this as well. So maybe there will be another item that we need to revisit later on. But so from an internal, so we can't release this yet, I guess. We have the first build where we can actually fit our target device with the intended design. Yeah.
Okay.
But,
and this is the -3 speed grade, right? It's the slowest part.
Yes, but timing is not met yet. So
okay. So you have the resource consumption there, but the timing is not quite there yet. Okay, gotcha.
So we reduced the number of failing paths from 10K to I think 4.5K. So it's now half the number of failing paths, and the duration of the path, the delays is smaller now. But yeah,
Right.
still some to go.
And
Right.
that's in large part just by fixing the inference issue.
Right. So this is
Okay.
heavily connected. So most of the failing paths are just RAM-to-RAM paths, and they are gone when we introduce the respective registers for this.
Right. Okay.
In addition, we will link to this, but it won't be part of the pull request because probably you don't want to merge this. So it would make things more complicated if we include it in this branch. There will be provided the formal verification environment we use to make sure that we don't introduce different behavior than the original one.
Gotcha. Okay.
So you can go through this and have a look and review or whatever.
Right. Well, so it's also possible on GitHub to create like a draft pull request or something like that basically can't be directly merged.
Okay.
So you're certainly welcome to open up draft pull requests for stuff like that, so people can take a look at it, or
Good,
even just
yeah.
normal ones. I mean, it's
Right. So yeah, we can do this as well. Yeah. Good idea. Yeah. Okay. Yeah. On the timing aspects, let's jump around a little bit. No, I have another thing with respect to the Intel things. So your first design, the initial one for the Stratix 10 MX board, did you actually check this running on the board, or did you just build it and say, okay, it's running throughs and that's it?
Oh, it works on the board.
Okay, cool. Great.
It works on the board. I mean, it's only a 10G design, so it's I guess I haven't experimented with getting that to work at 25G yet, but I don't think it'll be that big of a deal.
No problem.
Potentially could be a timing issue, but we'll see. I haven't really spent too much time working on that. The bigger issue is that for the research project, we need to run on a slightly different board. We need to run on the 520N MX, which has a different speed grade part, and it didn't close timing on there. So I'm like, all right, we got to cross that bridge first before I try to get it to run at 25 gig. But yeah, so it did close timing on the Stratix 10 MX, and yeah, I did get that working functionally. I mean, that was kind of the whole point of getting that design squared away, is so I could do the functional testing on there and make sure that yes, this is in fact working.
Right.
Such that we have a known good design we can start building on top of. So
good. Yeah. So that was just to cross check, because I did another port to the Stratix 10 dev kit, the Stratix 10 GX dev kit.
Okay.
And I guess I still have an open issue there to fix.
Timing wise,
okay.
or
yeah, I know there is some timing issues there as well, but I guess it's just a single corner that fails at 100 degrees, so that's not what we have in the lab.
It's probably going to be close enough to do a quick test on.
Right. I thought that it should at least I don't know, yeah, enumerate and exchange some packets, and then if it dies afterwards, okay. We're working on timing anyway.
So you haven't tested it yet. You built it, but you haven't actually put it on the board. Okay.
I did, and when loading the driver, everything crashed, so I have to figure out what happened. Let's see.
Okay.
I just wanted to make sure that I'm looking at the right places.
It should work.
Good.
In principle, it should work. Yeah. I guess the other thing on that is I don't think I've brought up all of the ancillary stuff yet. I've kind of been putting that on the back burner because it's like, okay, once I get this soft core operational, I'm going to have to redo all that anyway. So
right.
And I think that some of the Intel boards are a little bit more creative with how some of the stuff is wired up. So
exactly.
I don't think the Stratix 10 MX board was all that weird, but one of the other ones had this chip that sits between all of the all of the QSFP module, I2C interfaces and LEDs, and the I2C bus going to the FPGA. And I needed to take a closer look at the data sheet for that to figure out how you do anything.
Okay.
Yeah, it didn't look too
Interesting.
bad, but yeah, they got bump in the wire you got to deal with.
Right.
Every board has its quirks, so yeah, I figure once we get
Yeah,
some of
that's
the
right.
core logic sort of figured out, then we can start expanding on that. So anyway,
Good. Yeah, I guess that's, yeah, board support logic and how to refresh images and everything. I guess that's a little bit more complicated on the Intel side.
right, yeah, and I guess you guys are going to look at that to some extent, but it sounds like you're going to use the CVP, so maybe you are going to avoid that that issue a little bit.
Yeah, I try to, I think. Yes. Right. Yeah. Because yeah, interacting with the flash seems to be a little bit more complicated.
Right. I mean, it's just CVP kind of has its own logistical challenges associated with it, because you can't just give somebody a driver and then everything works. You got to give them a driver and an FPGA configuration file that's compatible with whatever is loaded into the flash. So,
Right. That's right. Yeah. Yeah, I will see. So not there's nothing set in stone yet, I guess.
right. Yeah, I guess the other thing I've wondered about with CVP is how much that ties you to a specific tool chain version. Although maybe you're going to do that anyway. But it's like if the CVP bit file or configuration image is generated with a particular version of the software, if that means you always have to use that same version, or if the CVP is simple enough to where it's a little bit more flexible. So I know with the Xilinx software, at least, you have to, I know you have to use like the DCP or something from the because for Xilinx supports something similar in terms of partial reconfiguration, so you can load the PCI Express interface before the rest of the user logic. But that's done with pure partial reconfiguration. So that's much more sensitive to the versions of both Vivado and also to the the outer shell component, if you will.
Yeah,
It
that's
wouldn't
right.
surprise me if you have to use the same version of Vivado, as well as pulling in that DCP if you want to, rebuild on top of the same, on top of that the same thing stored in Flash. Anyway.
Yeah, I think DCPs are tied to, well, DCPs are very flexible, so there's a lot of things you can put into a DCP, but it's, yeah, some kind of serialization of internal data structures. So it's not too generic, I guess.
Right, yeah. Anyway, I've not taken the plunge into partial reconfiguration yet. One of my colleagues, or a couple of my colleagues, are working on that, and it just sounded like a complete nightmare. So I'm like, all right, if I need that functionality, then fair enough. Otherwise, we'll put that on hold for now.
Yeah, so it's another complexity on its own. Yeah,
Definitely.
that's right.
Definitely. Any news with the DPDK driver that you guys are working on? I know it sounded like there were some signs of life.
Right. That's another topic for an upcoming PR. So we have some first packets exchanged through the DPDK driver, which is still based on an older revision of the MQNIC. So it's like a sometime
right, and
in
we'll
December.
Go ahead and we'll have to bring that up to date at some point, I guess. So
exactly, but I guess for a first initial review, that's fine. It's not, I don't know, it doesn't work differently when it's updated to the new register layout. So that's what's missing, and all the patches afterwards also. But yeah, so we were able to use it within this layer 2 forwarding example application. And we're just cleaning everything up, and we found another issue in our with another example application. But yeah, well, it's the first implementation, so
Right.
there
Yeah.
will be more
Okay.
issues popping up.
Got some kinks to sort out. All right.
Yeah, right.
And then it's
But
always
I
the
guess
question of, is this the driver or is this a a Corundum problem? Both are possible.
Yes, so yeah, that's always the first thing. Where do I have to look at? Yeah, so but we did something similar than the MQ dump tool, so that we
Right.
also have some debugging mechanism at hand.
Actually, so one thing that I was trying to figure out, if we're going to implement, a DPDK driver, that means we don't have access to, all the kernel faculties, right? Because you're connecting directly to the device. So that does raise maybe a few concerns in terms of, is it possible to use any of the user space tools, or does that have to be, re-implemented in some way to interface with DPDK? Or from what I guess, who was it that was asked, who was having a discussion with this with? Maybe it was Alex Padea. It seems like you might be able to poke at the PCIe device even when drivers and whatnot are attached. So I'm not sure if it's possible to use just a normal MQNIC dump utility against the PCI Express device directly, even with the DPDK driver attached. I'm not sure if you guys have tried that, but if that works, then that might be a major time saver.
I guess we came to the conclusion we need to adapt this into another tool. But
as in the interface isn't good, or you need to look at different information?
I wasn't part of this discussion actually,
Okay,
but Joachim is here as well, so maybe he remembers what they discussed.
It was just a quick decision to have something around for debugging, and the solution was simply to take the MQNIC dump tool and just include it into the application. I mean,
see.
It's all an application. Then it's, yes, there's a driver part, but it's in the end it's one binary. So it was more like copying and adjusting the access functions.
Right.
So no big deal. I mean, having MQNIC access the PCI function directly is I think is doable. E.g. via devmem like style, or accessing the resource node in sysfs.
Well, so all of the utilities should already be able to use the sysfs node directly. In fact, I think I actually made a modification in the most recent one. You can just specify the PCIe device ID after the -D switch, and it'll figure out where the node is. You don't have to put the whole path in. It's just a question of whether that's going to work with the DPDK application attached to the device, or if the kernel is going to prevent that somehow.
Yeah, that's the question which has to be answered. I don't know. It can be, perhaps it won't work because I don't know, because the driver, for example, this how it's called, the virtual function IO driver, which is binding to such a device in case of DPDK. I don't know. Perhaps it doesn't care. Perhaps.
Well, I mean, it's just I think it's going to
know.
be simple enough just to try it. You load your application, and then while that's running, you load the dump utility and see if it will talk to the device or not. If it works, it works. If it doesn't work, well, then we need a different solution.
Yeah. Okay. We will have a look at this. Yeah. We didn't even think about using it this way up until now, since it was kind of simple to just include the C code.
Right. Yeah. No, it would be nice to know just if that's going to be an option or
Yeah,
if that
yeah,
doesn't
sure.
work. So, is one thing that I noticed is that it seems like even when the normal driver is loaded, sometimes it works, sometimes it doesn't, and I'm not sure why. Like sometimes it seems to work just fine. Sometimes it complains about not being able to, open the device or something. So potentially that needs to be investigated a little bit further.
Yeah, this sounds like a bad sign.
Yeah, I mean, if it's just for debug tools, then that's fair enough. For a longer term, solution, then that we'll have to see. It's not something I've really investigated thoroughly, because I think the first time I tried that, it didn't work. It failed with some sort of an error. And then I'm like, oh, so the kernel must be preventing other stuff from accessing the sysfs thing when the driver is loaded. But then Alex Bidea said, no, it doesn't do that. And then I think I tried it again and it seemed to work fine. So I'm like, okay, I guess it works fine.
Yeah.
And then I went and looked at the kernel sources, and it seems like there is a way that you can ask the, when you're registering the memory regions in the driver, you can say, yeah, this is private, don't allow sysfs to operate, but the driver doesn't make that request. So it seems like it should work. But then I tried it again recently, and I was getting some sort of an error when I used the sysfs device instead of the /dev/mqnix0. So I haven't spent much time poking at it to see if I can see what's going on. It's possible I had a typo or something else. I don't know. So, I mean, it's worth trying. If it works, it works. If it doesn't work, it doesn't work. That would be a nice data point to have either way.
Yeah. But yeah, I kind of guess that the main question should be, I mean, this is a problem other DPTK drivers kind of also had. They had to be developed somehow, and people had to have debug tools. So my question would be, what's the correct way in DPTK to do such things?
Yeah, that's a good point. Yeah, probably we should do a little bit more research, figure out what the best method is for doing that. I guess the other option to consider as well is to add some sort of an interface to the driver that DPTK can attach to instead of using VFIO, or perhaps as an alternative to using VFIO. So you could do VFIO directly, or you can connect with some other interface. Not sure if that makes any sense, but then that would potentially allow the shim driver in this case to expose, the PCI Express interface and whatnot for the user space tools to poke at and configure stuff.
Yeah.
But I don't know. I'm not sure if that makes sense. Maybe it makes sense just to kick everything into the DPTK app.
We'll have to see.
Yeah. Agreed. Well, it's nice to know you guys are making some progress on that front, and it's definitely showing some signs of life. So that's a good thing.
Yeah, definitely.
All right. Anybody else have any
I guess
questions? Yeah.
We still have some questions. Sorry.
Yeah, sure. Go ahead.
One thing is like for I don't know, development process maybe. So when are you actually checking all your designs against timing and everything? Like you have like 10 boards or 12 boards, and how often do you run everything against those?
Well, I try to build everything at least before I push to the main Corundum repository. So I have a script that that runs both Vivado and Quartus across all of the boards, builds everything and then reports all of the high level timing parameters and whatnot. So I can see if something didn't build for some reason, if there was an error, or if stuff closed timing. So I'll run that, and I'll check to make sure everything closed timing except for And that FPGA Sumi always fails. The Exodus X10 sometimes fails. So I'm like, close enough.
Okay, yeah, right.
But
So
if
that
there's something
was my
concerning and they
question.
like all fail, then I'm like, uh-oh, I gotta take
Okay.
a look at something. Yeah, that's
Yeah,
usually how it
because
works. So
we asked the question to ourselves. So now when we provide these MLab fixes for the Intel devices, these inference things, so which other devices should we check for if we heard timing, right? And
right.
I was also
So
thinking, okay, let's pick the net
yeah,
FPGA
so
Zumi because
he
that's possibly the worst timing.
right. Yeah, but that one
FPGA.
usually doesn't close timing anyway. But hey, if it does close
Okay.
timing, then that's a good sign. So yeah.
No, it's a little bit better, but
the
not fixed.
right. Well, so the one thing that's really annoying about the Sumi is that it's quite often I will get a timing error that's inside of the PCI Express IP core block. And the timing error is like in between the hard IP block and one of the block RAMs that's directly connected to the hard IP block. I'm like, how do you even get a timing error there? Like there's no logic on the path. It's just the hard IP block connected to this block RAM that's just used dedicated to the hard IP block to use for something. And I'll get timing failures there, like really small ones. But it's like, it's inconsistent and there's nothing I can do about it because it's, it's inside of that that hard IP block. Usually the errors are elsewhere, but even if I'm not getting other errors from inside of Corundum, it's annoying.
Sounds
but yeah,
like
so
that,
you can try on that one, but if it fails, it fails, and that doesn't really mean all that much because it usually fails. But the Exodus X10 is a good one, and then I usually try on something like the U280 because that one fails pretty often just due to the placer being stupid. So if that one works, then you're good,
Okay, interesting data points because I built the U280 recently, so just upstream original code without all modifications, and it also kind of met timing. No, it actually failed, but yeah, not with a big stack. So okay,
right,
interesting.
Yeah. It's something about the SLR crossings in there and the locations of the transceivers versus the PCIe block. It's like basically the PCIe block is in the bottom SLR, and then the transceiver is in the top SLR. So you got to cross two crossings. And even though I have a bunch of pipeline registers in there, I have not like placed every single register into a particular SLR. So the tools are not very good at figuring out where to put stuff. It's
I already
annoying.
saw that you did quite some floor planning there. Yeah.
And I've tried a bunch of iterations on that, a bunch of different configurations, and I still haven't come up with something that meets timing reliably. So I figure it's not that big of a deal because as soon as somebody adds a bunch of application logic in there, then that'll probably go in the middle SLR and it'll probably clean up a lot of that. But
so we need to put some dummy app there that's just a large block of logic doing nothing, and then
yeah, something like that.
Pushing the placer to the edges. Okay, got it. Yeah, okay, that's interesting information. So maybe we do not focus too much on this, so that makes sense now.
Yeah. Well, I mean, the other thing is if you have a beefy machine, I can just send you the scripts that I use to run to build all the designs and then just let that run. So
yes. So just do this. I guess we might actually be interested in running those kind of regularly. At least on our changes, so that we kind of have an overview about if we do things, then we might help the Intel tools and even I don't know, put a roadblock in front of the Xilinx tools, so we don't want to have this one. Yeah.
Right. Yeah.
Okay.
Yeah, that's definitely true. And you're optimizing for something, you might end up breaking something else. So
right.
Unintentionally, but
Exactly.
Which I guess you said you've already run into a little of that, right? Introduce an issue while trying to change something. So that happens.
Yeah. Yep. That's iterative.
Right. All right.
Cool. I guess that were my questions. I think Joachim had another one, but yeah, then we are done actually, and we can let others take over. Sorry,
if
guys.
anybody else has any questions.
Yeah, it was just to have it said. We updated the TXQ selection
Right,
patch
yeah.
to the
Oh,
current
so
master.
yeah, I was just taking a look at that. I have not, put together a bunch of comments yet on that. I guess the couple of things that I was trying to figure out is kind of how so you added some module parameters here. One of them is to enable the select queue handler capability per interface.
Yeah.
What exactly goes into that parameter? Is that like a list of Ethernet device names or PCIe?
No,
PDFs, or
that's just a standard kernel module parameter, which takes an array, and these arrays in these cases just take Boolean values. I mean, you can have arrays of integers or of strings, I guess, and in this case, it's just Booleans.
And those Booleans represent what exactly? Like
represent the interfaces. So the first one is the enable or disable switch, depending on how we do it, for the first interface, the second one for the second, and so forth.
And what if you have 2 or 3 cards installed in the same machine?
Yeah, that's a good point.
I'm wondering if we need these parameters at all. My thought is, I mean, it's like adding configuration options is great, but there's always a question of if you really need to have an option for something. So I'm wondering if the first time somebody tries to register this callback, if you can enable the callback at that time, basically. Maybe that doesn't work, but if you can do that, then you don't need the configuration options, because as soon as you try to use it, then it'll just enable it, and then you're good, right? Because I think your concern with just making this always active is that it could be detrimental to performance, possibly, if you're not using this feature, right?
Yeah,
I think that was your concern. Yeah.
So basically, this decides about whether the callback in the net device operations is there or not. And I mean, as far as I know, this has to be done on probing when registering the network device.
Okay, so after it's registered, that you can't change the entries in that table. Seems like, right?
Yeah, that's my kind of, I would say, strong assumption.
Or I guess
it's the like only thing which
or
makes
it's like
sense.
Maybe you could, but there might not be a safe way of doing that.
Yeah. Yeah, and just to acknowledge that, yes, the thought was to not have the callback at all if we don't need it. That's the thought behind that. If performance doesn't matter, we kind of don't need to think about that.
Right. Yeah.
But I mean, this driver should be usable with the 100 gig designs, and I guess if a machine can do, say, 100 gig without that callback, then that's what the machine should do. But only because we have that callback in there, and then that particular machine doesn't make it anymore, well, that sounds like not nice. So that it's just a performance thinking.
Right. Yeah. Well, what is the default anyway? I know the Linux kernel has some default handler that it uses if that table entry is not set. I guess this is going to require a little bit of poking around to figure out what that original one is. I guess I guess ostensibly, yeah. So I guess the question is that if you do set the callback but don't use it, what is that performance penalty? And if you
Right.
can
Yeah.
optimize
Yeah.
it so that
That's the question.
that's low
Yeah.
overhead. Yeah. Yeah, because
I
there's
mean,
also
in
a
the kernel,
trade-off
it's a
between.
check for null value.
Yeah.
And if the value is not null, if the pointer is set, then the function gets called and needs to do something. I mean, that's the other thing. It's not that, yeah, we can have that pointer, and if we don't need it, we just don't do anything. Then we have to do something. And that something is basically, or needs to be at least what the kernel would do if the pointer wasn't there.
Right. Well, you might be able to just call the function that the kernel is running. Right.
Yeah,
I
right.
mean,
That's
is that what you do if
I
this is not
did,
set?
yeah.
So yeah, okay. I was just noticing that we have a whole bunch of different prototypes based on the Linux kernel version. That's kind of annoying, but I guess there's not much you can do about that with internal kernel stuff changing.
Yeah. No, we have to live with that, I guess. It even gets more complicated as soon as we introduce Red Hat support.
Yeah. Oh, right. Yeah. Okay. So I noticed you have a check for even 4.19, but I guess that's not the Red Hat check yet.
No, not yet. That's a separate
Okay.
one.
How much stuff do we have to poke at with the Red Hat support? Does that cover a bunch of stuff, or is it pretty straightforward?
It's straightforward. I think it was 3 changes, 3 places.
Oh, okay.
If I'm correct. I have to look it up.
Bad.
That's not too bad. Yeah, that's a CentOS 8 at least. For CentOS 7, I guess it would be a catastrophe.
Right. Yeah. Yeah, I can't remember if I was looking at CentOS 7 or something the last time somebody asked me about, hey, does this thing run on CentOS? I'm like,
yeah, I guess it was CentOS 7. You said something about CentOS 7,
maybe.
I remember.
Well, when did 8 come out? I guess 8 must have come out pretty recently.
In terms of Red Hat, I guess you can say recently. In terms of
when was the first version of CentOS 8 released? Or do you know offhand, like approximately what year?
It was released with 4.18 because that's their kernel, I would say. And I guess it would be a little bit even younger than 4.18.
Okay.
Speculate. I don't know.
So Wikipedia says CentOS 8 release date 24th of September 2019.
Okay.
What?
Yeah, I think.
Okay. As I said, younger than.
I think the last time that I looked at CentOS, 8 wasn't released yet. So.
Okay. Okay, I did say nothing.
Yeah. All right. So yeah, that was my reaction when I looked at the kernel version and CentOS 7. I'm like, are you kidding me? When was this released? Like last year? Really? CentOS 8 definitely brings it up a few versions. So it's not current, but it's more recent. It's less ancient. Oh boy.
Okay, but I have to say, my latest discovery was that, I mean, at least in CentOS, you have their Red Hat Enterprise version numbers for the kernel, and you can check them.
Right.
Ubuntu, I recently found out, also does kernel changes in a way which makes it incompatible with the reported versions. And up until now, I didn't find a way to check. Yeah, well, against.
Well, like what are they
changing?
Are they actually changing internal kernel API stuff, or?
Right. Yeah. Yeah.
Oh.
They're doing what Red Hat does, importing newer stuff, changing API. But Red Hat then
They
bumps
actually
up
have a
their
release version that you
version
can look
number.
at.
Yeah. And for
Interesting.
Ubuntu, I just did not see it. It was not obvious. I don't know yet, but I was surprised.
That's interesting. Yeah. I mean, I guess some of that you might be able to. Yeah, I guess you can always if-def it, but if-def it based on what? If they don't have a. If you can look at the presence of a symbol, then
Yeah.
that's one thing. But if you're changing, what arguments are attached to something, then that's a different problem. Oof.
Yeah, I mean, it's not a problem we have to solve here for our project, but it was an interesting find. And I wonder if they have a separate version definition, which I just didn't find.
Yeah, I mean, it's also possible that they just don't. And that
Yeah.
you're not expected to do out of tree kernel stuff with Ubuntu.
Yeah, I
Yikes.
guess
That's
that
problematic.
was something where they this was a severe bug fix which they included, and the bug fix commit kind of also changed the API, and that was also something. Well, I wondered, why do they do these things? Change the API together with the bug fix. Perhaps it wasn't possible otherwise. I don't know.
Well, that leads me to believe that maybe they're not doing it to the same extent as Red Hat, right? Only if it's like a small bug, then they'll backport it for security reasons or whatever. Otherwise, they might not do that.
That seems like it, yes.
I certainly hope
at least
that's the case anyway. Oh boy.
Yeah, okay. Multi-card issue. I didn't think about that at all, to be honest.
Yeah, because I was thinking about that a little bit. I'm like, I think I saw that that array, and I'm like trying to get my head wrapped around what exactly you're putting in there. Originally, I'm thinking, well, you can't put Ethernet device names because you don't know the Ethernet device name until the thing is actually registered, because the name could change. In fact, I think the name is pretty much guaranteed to change by UDEV or whatever.
Right.
You could put the PCIe device ID in there, but that doesn't tell you which port. So
yeah, but perhaps that would be kind of a basic idea to take,
right. Yeah, but
PCI
I guess
ID plus another identifier attached to it.
Right. But I mean, I guess the alternative way to do this is that maybe we just take the small performance hit of having one internal check or one internal pointer or indirection or something like that. We eat that, which was probably going to be small, and then we avoid having to add all this additional complexity for configuring and parameters and stuff like that.
Yeah. The other thing I already thought about, because you said, at least I understood it like this, that as soon as you have all the infrastructure in place within the FPGA, you would go ahead and change the driver so that interfaces are created. I have to say, Linux NetDevs are created on demand for a certain combination of MQNIC interface plus ports. So if MQNIC interface has multiple ports, there could be, let's say, 2 NetDevs per one MQNIC interface because it has multiple ports, something like that. And for these cases, I guess we would then have such an RT-Netlink interface for creating new links, meaning NetDevs, which in these cases could then include parameters on creating these interfaces, which can say, I want to have that option or I don't want to have that option.
Interesting. Yeah, this is not something I've really looked into yet. So to be honest, my My priority is to get the kind of overall driver architecture and the hardware into a position where we can support this kind of stuff. But then, since it's not something that I need, I can't really sit down and hammer out the driver to actually implement all the APIs and whatnot for doing this. So as far as do we do this dynamically at runtime, or do we do this based on some other parameters that are specified in the register space? Not sure. I'm definitely open to working with you guys to kind of figure out what that interface should look like, and what you guys need for your application and whatnot, and what makes sense to implement it, and then you guys can do the implementation on that so that it works for your application. So I'm not planning on pulling the rug out from under you guys in terms of totally changing up that implementation.
Okay.
The re-architecting and reorganization is just to make that easier when we do need to change something there. So yeah, to be honest, I'm not even sure exactly what that should look like at this point. So that's definitely a discussion point.
Okay. So the takeaway is there is a better way, a kind of clean way to do this. But well, we don't have it yet in the driver, so we can use it away.
Right. And then I guess the other question is how much backporting needs to be done. We do this on CentOS 7.
No, RT Netlink is rather old.
Oh, that's been around for a while. Okay. It's old enough to at least be in 4.18 or whatever they're running. Okay.
It's so old that it's called RT Netlink. It's a routing table, the routing table code, which was introduced, I don't know, 20 years ago to change the routing table. And they enhanced that to also manage links, as far as I understand. So it's called RT Netlink, which is based...
I was getting my wires crossed with DevLink, which I think is a much newer interface.
Right, that's something different, I would say. Yes.
Okay, so RT Netlink is the more relevant one for what we're doing. Okay.
In this case, I would say yes.
Okay, gotcha.
So all the tunnel implementations in the kernel uses to dynamically create tunnel endpoints, for example.
The ton and tap interfaces. Yeah, okay. That's through RT Netlink.
Yeah.
But is it also possible to create them on particular devices?
Yeah, sure.
Okay.
It's a generic and extensible interface to create network devices dynamically on demand by user space. And you can have kind of any parameter. They have a few types predefined, but you can basically have anything, byte arrays, communicated back and forth. It's based on Netlink, which is a socket-based user space kernel space interface. And yeah, in this universe, there's this thing called RT Netlink for link management. Most of the time, I'm not really sure what the correct name is, because naming things, well.
Yeah. All right. Well, I can certainly take a look at that, see if I can familiarize myself with what those API calls would be on the driver end. To be honest, my thought wasn't necessarily to do this dynamically.
Okay.
But to basically, kind of my first thought is that we can add a configuration bit somewhere that just says, instead of interfacing, or instead of instantiating one net device per interface, give me one per port, right? And then the driver would do that. And then that would just be done while initializing everything. And, and just keep it at that. But then if you wanted to do something something asymmetric where you want to have, per port on this interface, but not on this other interface, I have to do some thinking about that.
Yeah.
I'm not sure if the parameterization is quite set up to handle something like that. Potentially could be done though. But yeah, that's kind of my thought on that. Does that seem like it would be sufficient for what you guys are doing?
I'm not sure.
We would have to put some thought into that. That's fine.
The point is the current model. I would say, first of all, the current driver model, how it's done, plus this TXQ selection is, I guess, what we can use right now. There's no need to change.
Right.
With the RT nettling topic and dynamically creating interfaces, I was kind of thinking ahead of our project, more or less in a generic way, what could make sense.
Okay.
As soon as the MQNIC gets the ability to, have these flexible assignments, port to NetDev, whatever.
Right. Okay. All right. Yeah, so my understanding is that you mainly wanted to do that kind of statically for resource reasons, right?
Yes,
multiple ports without consuming a whole lot of logic. So you don't really need to do things dynamically.
Right.
But yeah, I guess potentially there would be a use case for doing that, because I guess potentially there would be a use case for doing that. But at some point, then you start getting into how are you going to allocate all the various internal resources and whatnot, right? I mean, kind of my thought is that each of the ports would have its own scheduler and whatnot. That you'd have a nice kind of one-to-one mapping of all of that. But yeah, if you weren't going to maintain that, if you wanted to do something more dynamic, you'd have to figure out how that would work. I mean, for something like DPDK, you can do whatever you want. It's pretty straightforward. But if you're going through the, I'm not going to say it's straightforward, but at least you're not fighting the Linux kernel in the Linux kernel networking stack. But if you are going through the Linux kernel networking stack, then maybe you need to be a little bit more constrained and less dynamic. But I don't know. This is definitely good points for discussion that we'll have to put some thought into, though.
Yeah.
Not sure at this point. It's not super clear what the long-term solution is going to be.
So in the end, for kind of this first pull request or queue selection feature, we kind of have to decide now. Yeah, what do we want? Do we go the route, as you said? Let's take the potential performance hit and just go without the parameters and have it in all cases. I mean, the other possibility is to go back to a compile time option, to say, well, either you enable it at compile time and then it's enabled, or you just keep it out and don't compile it. That would be another kind of intermediate solution.
Right. Well, let me take another pass over this here just to figure out what the story is. I guess we have. Right. Okay. So MQNIC select Q, that's just going to replace the default, right? So it calls that function instead of the default when this is enabled. And then inside of that, we have RCU dereference, and then you call it. Otherwise, you do the fallback.
Yeah. And the fallback is basically what the kernel does.
I see. And what that explains why we have all the strange parameters, because that's what the fallback takes. Or no, I guess the NGO select Q itself has changed. I see.
Yeah. they changed the API there over these versions. And that's why it kind of looks like not nice.
Right. Okay. Yeah, what are you going to do about that? Yeah. I mean, I guess there really isn't any way to make this simpler, right? I mean, RCU dereference, you kind of have to call that to get the pointer. Again, the whole point of RCU is to be able to do atomic updates of that pointer, I think, right? Something about that.
Yeah.
That allows you to swap that pointer out without screwing things up massively.
Right. Yeah.
Yeah, maybe we'll just have to do some benchmarking with this and just see what it does to the performance. Well, you were talking about potentially getting this sort of thing upstreamed at some point, right?
Yeah.
Maybe.
Yeah.
But I guess that wouldn't really help you with CentOS.
No, but
10 years from now, maybe.
No, that was never a realistic goal, I would say. But I guess a realistic goal would be to ask upstream, what they think about this functionality, and perhaps include it into the kernel itself, so that this callback is checked within the kernel, not within the driver.
I mean, to be honest, there are all sorts of weird quirks about the network stack that make very little sense. Like, why is a device driver making the determination of which transmit queue to use? It just seems weird to me. It seems like somebody else would want to have more control over that than whatever the device driver happens to implement. It's surprising something like this wasn't implemented previously, if somebody wants to do something funky.
Yeah, good question, good point. I mean, the most obvious thought which comes up is simply, well, this has to be done via TC somehow.
Right. Yeah, well, TC does have provisions for changing the queues.
Yeah, I mean,
I don't know what the performance of that is. That's something that I probably need to look at some point. Last time I tried it, I mean, it worked, but there were some significant performance penalties, but I'm not sure if that was due to the queue rewriting or just going through TC in general.
No, I mean, the traffic is, as far as I know, is always going through TC. It's going through the standard queue.
So when I added that TC filter, the performance changed significantly. So I don't know if it was something just like how that particular component was implemented or something. Like it was forcing everything to go through the same CPU core or something weird, and the performance significantly changed. Although I haven't looked at that in a while, so I don't know if modifications have been made or what. But yeah, potentially we'd have to do some sort of a callback anyway to solve that. Well, I guess, yeah, okay. All right, well,
I mean, the third option is obviously to kind of suspend the topic. And I mean, as far as our project is concerned, our goals, we just include it in our private branch.
It's a relatively simple patch to add on there. It doesn't make too many changes. It's mostly just a couple of additions. So
yeah.
Yeah. All right. Well, we can ruminate on this a little bit and then circle back to it a little bit later, perhaps.
Yeah, sounds good.
All right. Anything else that people want to discuss? Or looks like most people have signed off for the day since we are over time at this point. So Yeah, means we had a good discussion, right?
Yeah.
Adam, John, do you got anything that you want to add or anything, or
No, I wanted to
just
ask
listening
about
in?
DPDK, but it was already discussed.
Okay. Well, you guys, you said you were planning on doing some stuff with DPDK on your end, right?
Yes, yes, yes.
Okay.
So I wanted to ask Ulrich about their progress, and we are waiting for that.
Yeah. I think there's quite a bit of interest in the
It would-
community over DPDK, so it'll definitely be
Yes,
nice
yes.
to have that available.
Yes, everyone. I think a lot of people are waiting for that. We have some DPDK guys. They are currently working with CP and things like that, 10 gigabit, but for 100 gig for Corundum, they are waiting for, and they
The
will.
initial version.
Yes, they will. They are planning to design better products. So if you finish the DPDK, it would be good for us too, actually. And we think a lot of people will be happy with that.
I mean,
Cool,
the problem that I've always run into is there's a lot of people saying, "Hey, do you support DPDK yet?" I'm like, "Well, that's something we're planning on. Do you want to help?" But then I don't hear anything. So, the guys that you have at your company, do they do much, low level stuff? Would they be interested in helping with the implementation of the DPDK PMD, or are they more interested in just using it?
They also, if it does not come quickly, of course they will help if you want. So there are people working on that already, and if it comes quickly, of course they will use it. But if it takes longer time, of course they will help, and they can help.
All right.
Sounds good.
So I will thank everyone.
Oh, wait,
I
did
will thank
William want to
anyone
say
who
something? Hang on
Oh,
a second.
sorry, I joined late. I missed most of the conversation about DPDK. Is it okay to ask which company are interested in doing DPDK? Or?
Yeah, sure. Is this the first time you've joined a meeting, William?
Yeah, kind of.
Okay.
So.
All right. Not gonna argue with that, or maybe even follow along on YouTube. I mean, I try to get these up some point regularly.
Yeah. All right.
All right. So you're asking about which companies? So
Yeah.
I know Ulrich and Joachim are with Missing Link Electronics, and Adam, John, what was your company again? Drawing a blank on what it was called.
Bull Tech.
Bull Tech. Okay.
Yes,
I was thinking
yes.
boss.
It's
I'm like, I don't think
startup
it's boss.
company.
Okay, Bull. Yeah, right.
Yes, we call it Bull in
Bull
Turkish.
Technology.
Actually, it's B-Ul.
Just is there a website? BO.
No, we don't have website yet. We connect with others using LinkedIn. So it's new company. We are just there are just 12 people now in R&D, and we are becoming. We are expanding, but it's very new company.
Okay. I wasn't sure if it's okay to connect with you offline. Is there a way that I can reach out to you, or?
Oh, thanks. Sure.
Is it okay to?
Sure. Anytime. Anytime. Yes,
Yeah,
yes.
I think everybody on here should be on the Slack channel and whatnot. So,
Yes,
we
yes. You
probably
can
go hunt
find
people
me
down on there.
in Slack channel.
Oh, there's a Slack. Okay.
Slack workspace. I'll post a link. One moment here.
Yeah, if you could, if you don't mind sharing the link on the chat.
Yeah, I'll do that. I just need to go grab it.
Okay.
I don't have it in front of me at the moment. The annoying thing about Slack is I can't just, copy the link out of Slack because it's like a separate invite link sort of thing. It's kind of annoying, but
Yeah.
anyway, one moment. There you go. That should be
Oh.
that should be the one.
Okay, and who was the I'm trying to get the name of person. It was that
Who is the person? What?
Shukrova? Was that okay? Who was the person who was talking earlier? Trying to.
Shukuro, Adam John Shukuro.
Okay. All right. Okay.
Okay.
I try to find. All right. Sorry about that if I butchered the name. Yeah.
Yes.
You could just go into the Slack space and there is a DPDK channel on if you want to specifically talk about DPDK actually.
Okay. And
There
through
are other.
Okay, through the Slack. Okay.
Yeah, we got a bunch of channels, but it seems like a lot of people don't go looking to see what channels are available. I'm debating if I should just make most of them defaults so that people can actually see what's going on.
Okay.
To be honest, I didn't know anything about Slack
Yeah, okay.
before recently. Yeah.
I'm new
Until
to that.
recent.
So, okay. So
Yeah,
in this,
I try to make announcements periodically in the general channel saying, hey, take a look at the channels that we have available, but I don't know, I guess people don't know what that means.
okay.
Anyway,
Thanks.
yeah, sure.
Thanks, everyone. Ulrich, Joachim, William, Alex.
All right. Well, see all you guys in 2 weeks then.
Yes, and hope everything will be okay. We'll be alive.
Yeah, well, yeah, hopefully World War III does not start in the next 2 weeks, you know.
Yes, yes.
Oh man.
Maybe we'll have our rifles in our hand.
Well, yeah. I mean, not much I can do here from San Diego, but yeah. Let's see. So you're in Turkey, and then Ulrich and
Alberta is
Joachim are
safe.
in what?
Alberta is safe. You
Safe in
might be
Switzerland,
safe
yeah.
because you are far away from here.
So, you know, Ulrich and Joachim, I think, are in Germany, right? So that's
Yes, Germany. I
the
don't think
relative
it's
ballpark, but yeah, a little ways
Yes.
away. So
and my country might be safe because no one knows it. It's
well, yeah, fair enough.
my weather. Okay. Okay, see you guys.
All right.
See you, everybody.
All right. See
Thanks
you
a lot.
guys.
Thanks. Bye.
Thank
Bye-bye.
you.